In today's lesson, we shall be looking at application of differentiation. In our previous lessons, we learned about differentiation from first limit, from first principle, differentiating with the various rules. Today, we shall be looking at application of differentiation. And in our lessons, after the lesson, you should be able to, we are going to do that is increasing and decreasing functions. What are they? When do we say a function is increasing and then decreasing? We shall also be looking at gradient, tangent, and normal. And then also stationary points and stationary values. After that, we'll also be looking at classification of stationary point, that is maximum and minimum. And we'll also be looking at the application of the maximum and minimum. After that, we'll also be looking at curve sketch and how do we sketch curves. And then also would consider rates of change. And then in our last lesson, we shall be dealing with small increment, that is approximate changes. Calculus, we have a whole lot of things to do. Make sure that you keep watching. So let's start. Our first is increasing and decreasing functions. Now, when do we say a function is increasing? So we consider increasing functions. Now, if we have a curve, if we have this curve, let's suppose that this is x1 and then also we have x2. Now this is y equal to f of x. Clearly there will be a corresponding value of the y. So here will be fx of 1. And then the x2 would also give us, that is fx2. There's the x-axis, there's the y-axis. Clearly, what can we see? We can see that x1 is less or equal to x2. So if x1 is less or equal to x2, and we have, clearly, what can we see? F of x1 is less or equal to f of x2. Then we say this function is increasing. On the other hand, if we have that decreasing function, if we have a curve, and then let's suppose that the curve is just like this. So let's suppose we have, this is x1, this is x2, and clearly this is giving us, that is f of x2, and this would also give us f of x1. Now let's suppose that this is y equal to the function f of x. This is our y-axis, this is our x-axis. Now let's see, clearly we can see that x1 is less or equal to x2. So if x1 is less or equal to x2, now let's see, what is f of x1? F of x1 is greater than what? F of x2. So f of x1 greater or equal to f of x2. Then we have a decreasing function. So first, if x1 is less or equal to x2 and f of x1 is less or equal to, that is f of x2, then we say the function is increasing. On the other hand, if x1 is less or equal to x2, implies that that is the f of x1 is greater or equal to f of x2, then we say the function is decreasing. So our first lesson is on increasing and decreasing functions. Now, when do we say a function is increasing? Now let's consider a curve. This is our x-axis, and then this is our y-axis. Now let's consider this curve. this is y equal to f of x. Now let's suppose it is on an open interval. So we have, this is our x1, and then this is also our x2. Now I want to find our f of x. So clearly if this x1 and this is touching this, our f of x1, our y value, the corresponding y value, we'll get it here, that is f of x1. And then x2 would also provide us with f of x2. Now, we say that a function like this is increasing if x1 is less or equal to x2, implies f of, let's see, x1 here is giving us what? F of x1. Clearly, f of x1 is less than what? F of less or equal to f of x2. So we say that a function is increasing if x1 is less or equal to x2, implies that f of x1 is less or equal to f of x2. Then we say the function is increasing. Let's also consider decreasing. Now, if we have a curve, let's suppose that this is the curve that we have, and we have a curve like this. Now, this is the curve that is y equal to f of x. Now, this is the x-axis, this is the y-axis. So this will be our x1, then this will be our x2. Now, x1 will give us its corresponding y value, which is f of x1. And then x2 will give us its corresponding value, which is f of x2. Now, the condition says that if x1 is less or equal to x2, implies that f of x1 is greater or equal to f of x2, then we say the function is decreasing. So now we know of these two conditions. The first condition says that if x1 is less or equal to x2 and f of x1 is less or equal to f of x2, then we say the function is increasing. On the other hand, if x1 is less or equal to x2 and f of x1 is greater or equal to f of x2, then we say the function is decreasing. And I would like to look at increasing and decreasing theorem. If y is a differentiable function on an open interval, that is, if y is a differentiable function on an open interval for all x, a member of, that is the open interval AB, then we say that the first one, if the y dx is greater than 0, then y is an increasing function. So when we differentiate and it is greater than 0, then we say it is an increasing function. On the other hand, if the y dx is less than 0, then y is a decreasing. So that's what the theorem is saying. If y is a differentiable function on an open interval for all x, a member of AB, that is this an open interval, then if the differential is greater than 0, then we say it is an increasing function, and if the differential is less than 0, then we say it is a decreasing function. Now let's consider examples for better understanding. Let's consider the first example. Show that y equal to x cubed minus 3x squared plus 3x plus 1 increases for all real values of x. Now you have y to be equal to x cubed minus 3x squared plus 3x plus 1. Now from the theorem, let's differentiate this. So dy dx. Now this will give us 3x squared minus 6x plus 3. Now they are saying that we should show if this increases for all values, for all real values. Now let's see. So clearly, what is common here, we can say that clearly we can factorize 3 out. So when you factorize 3 out, you get x squared minus 2x plus 1. And x squared minus 2x plus 1, this is quadratic, and we have to factorize. And when you factorize, you are going to get, that is x minus 1 all squared. You have, your algebra should be very, very strong. Now, here, for all values of x, we can see that if we choose all values which are greater than 1, we know that this is an increasing function. There's no way that this is going to be a decreasing function. So here, so we know that the y, the x, which is equal to this, is greater or equal to 0 for all values of x. So if we choose even negative values, when you choose even negative values, this will be greater or equal to 0. Find the intervals where the curve y equal to x cubed over 3 plus x squared over 2 minus 2x minus 3 is decreasing. What do we know? So the function, we have s cubed over 3 plus x squared over 2 minus 2x minus 3. Now, the function, that is y, is decreasing if, that is, the y, the x is less than 0. So the function is decreasing if the differential is less than 0. So let's differentiate the y dx. Now when you differentiate this, what are we getting? 3 over 3 x squared plus 2 over 2x minus 2. Now this is giving us x squared plus x minus 2. And because we are being told the function is decreasing, clearly the dy dx should be less than 0. So we have x squared plus x minus 2 less than 0. What are we supposed to do? We are supposed to factorize this. Two numbers, when you multiply, we will get negative 2, but when you add, we will get positive 1. So you have x squared plus 2x minus x minus 2 less than 0. Now from here, factorizing, so we get x, and then we have, that is x plus 2 minus 1x plus 2 less than 0. Now what can we see here? X plus 2 is common, so we have to factorize x plus 2 out. What is left here? We have x and then minus 1 less than 0. And clearly this is a quadratic inequality. So what are we supposed to do? We are supposed to sketch a curve. Now let's sketch. Now when it's equal to 0, we'll get negative 2 and positive 1. So we have negative 2 here, and then we have positive 1. And clearly, because the coefficient of the x squared is positive, this will give us a minimum curve. So we have this curve. Now we want the part of the curve which is less than 0, and beneath is less than 0. So this side is less than 0. So our values is, that is x is greater than negative 2, and then the x is less than 1. Let's consider this example. It is given that f of x is equal to 1 over x cubed minus x to the power 3 for x greater than 0. We show that f is a decreasing function. Now, so our function f of x is 1 over s cubed minus x to the power 3. Now, from here, indices, we know if we have a to the power negative n, it is equal to 1 over an. Or if you have 1 over an, it is equal to 1 over n. So clearly we have this will change to x to the power negative 3 minus x to the power 3. Now for a deeper understanding on indices, make sure you watch my previous videos on indices. Now from here, what are we supposed to do? What is the condition? We know that a function is said to be decreasing if its differential is less than 0. Let's find the differential over here. When you differentiate this, this will give us negative 3x negative 3 minus 1. It will reduce by 1. When you differentiate this, you get 3x3 minus 1. So this is negative 3x minus 4 minus 3x squared. Now from here, what is common? We can see that we have negative 3 here. We also have negative 3 here. So we can factorize the negative 3 out. And then also we have x to the power negative 4. We know if you have a to the power negative n, it is equal to 1 over an. So we would apply this property over here. So we have negative 3 all over x to the power 4 minus 3x squared. Now you can see negative 3 is common. So you can factorize negative 3 out. What do you have? 1 over x to the power 4 plus, that is x to the power 2. Now, when you multiply this time, this, you know, numerator times numerator, denominator times denominator. So you get negative 3 over x to the power 4, and this is also going to that. Now, we are being given a condition that the x is greater than 0. X is greater than 0. So we can't choose when x is 0, but you can choose when x is 1. And for any value of x, when we put it in this will give us negative. For any value of x greater than 0, when you put it in this, it is going to give us a value which is less than 0. So clearly, from here, this is less than 0 for all x greater than 0. Why? We have a negative value here. So whatever we have here, when you multiply by this, we are going to get a negative value. Hence, this is a decreasing function. We are being told to show. So here we've been able to prove that this is a decreasing function. Now let's consider our next example. A function f is defined on the set R of real numbers by f of x, which is mapping onto 2 over 3x cubed minus 5 over 2x squared minus 3x plus 1 over 6. We should determine the values of x for which the function is increasing. Now we know that f is increasing when our first differential is greater than 0. Now what is f of x? F of x is 2 over 3 x to the power 3 minus 5 over 2 x to the power 2 minus 3 x plus 1 over 6. Now let's find the differential of this. When you differentiate this, from our idea of the first lesson that we had, if you are not getting it well, kindly go back and then watch that lesson for a better understanding. Now when I differentiate this, I'll get 2x squared minus 5x minus 3. Now we are being told that the function is increasing. So since f is increasing, this implies that f prime of x is greater than 0. Now, the function is greater than 0. So what is the differential? That is 2x squared minus 5x minus 3 greater than 0. Now, this is a quadratic, and this is type 2. We have to factorize this. What's the coefficient of x squared? The coefficient of x squared is 2. Positive 2, so we have to multiply it by the constant term. So 2 times negative 3, that's giving us negative 6. So two numbers, when you multiply, we get negative 6. And then when you add these two, we are going to get the middle one, which is negative 5. And clearly, these values are 6, that is negative 6, and then positive 1. So negative 6 times 1, that is negative 6. And then negative 6 plus 1 will give us the negative 5. So when we factorize this, we are going to get, that is 2x squared minus 6x plus x minus 3 greater than 0. Now what is common? 2x is common, 2x. So we have x minus 3 plus 1, x minus 3 greater than 0. So we have x minus 3, we factorize x minus 3 out. What is left? That is 2x plus 1 greater than 0. Now, what do we have here? We have a quadratic inequality. And since it is a quadratic inequality, we have to sketch a curve. If you've forgotten it, make sure you go and watch my videos on quadratic inequality. It is a very interesting topic, I thought. Now, let's see. So from here, we have to sketch. This is a minimum curve. Why is it a minimum curve? It is a minimum curve because the coefficient of the x squared is positive. And when x is 0, when this is equal to 0, we'll get positive 3 and negative 1 over 2. So negative, this negative 1 over 2, and then we have the 3 here. Now this is a minimum curve. So we have a curve like this. We want the part which is greater than 0, and all the values above is greater than 0, all the values beneath is less than 0. So clearly we'd get the values over here, and then all the values to over there. So for this, we know clearly, look at this, what are the values over here? X is less than negative 1 over 2 because all the values over here less than, or x is greater than the values on the right of 3, greater than, that is 3. So this is the range of values.